Day 503 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3408, Design Task Manager. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a task management system that allows users to manage their tasks, each associated with a priority. The system should efficiently handle adding, modifying, executing, and removing tasks. Implement the Task Manager class. Task Manager initializes the Task Manager with a list of user task priority tripled. Each element in the input list is a form of user ID, task ID, and priority, which adds a task to the specified user with a given priority. The add function adds a task with the specified task ID and priority to the user with the user ID. It is guaranteed that the task ID does not exist in the system. The edit function updates the priority of the existing task ID to new priority. It is guaranteed that the task ID exists in the system. The remove function removes the task identified by task ID from the system. It is guaranteed that the task ID exists in the system. And the exec top function executes the task with the highest priority across all the users. If there are multiple tasks with the same highest priority, execute the one with the highest task ID. After executing, the task ID is removed from the system. Return the user ID associated with the executed task. If no tasks are available, return -1. Note that a user may be assigned multiple tasks. All right, y'all. So that may seem like a lot to take in at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get started, I'm going to just copy and paste this over here for y'all so we can get a better visual representation of what is going on. I know it may seem like a lot, but it's not that bad. So let me just clean this up. So this is our input. Let me clean this up. Okay, boom. So this is our input and this is our output. So what this input represents, we initialize the task manager, then we call the add function, then we call the edit function, then we call the exec top function, then we call the remove function, then we call the add function, then we call the exec top function, right? Then this is our output, and this is what we're starting with. These are the user's task IDs and priorities that we're starting with. And these are the inputs that we are going to input into here when we call these functions. So and then this will be our final output. So we're going to go through the example or the explanation just so it makes more sense and you can see what's really going on. But that's just the basic gist of it. So let me do this. This is where we're going to put our output. And then let me just copy and paste this. So this is what we're going to be mutating. It's just a copy of this, but I'm going to show you how we mutate this when we call these functions. I'm going to show you that mutation here in this array. And then this will be our output array. And this array right here should match this array when we're all said and done with getting through this explanation. So let's see how they got this output from this input. Boom. So first thing, we have our task manager. So the task manager equals new task manager. Boom. So we're just initializing this. Boom. So we have to initialize this with our 3 users. This 1 represents a user. This 2 is a user. This 3 is a user. Then this index 1 right here, this is the task. So task 101, task 102, task 103, and then this right here, this 10, 20, and 15 represent the priority of each task. So now let's get started. Once again, we're initializing the class. Boom. So boom, we have the class right here. It's initialized with this array right here. Boom. Then we calling, so we did that. Boom, we could get rid of this. Boom, we called that function, and we could put null right here because we already called that function. So the next function we're calling is add. Boom, so we're calling add. So it says task manager, we call add. So since it's add, we're gonna come right here to index. Since add is right here, we're coming right here. This is what we're adding. We're adding user for task 104 with a priority of 5. So that's going to add this to our class. So like I said, this is where we're mutating this. So we can just add this right here. Boom. So we add this right here. Or we could add it both just so it makes more sense. We could add it here too. Boom. So we added it. Boom. So after we add it, we could just put another null right here because all we did was add. We didn't return anything. So we could just put null. Boom. So we called that function. We could get rid of this, and we could get rid of this just so it's no confusion as to where we are. So now we're at edit. Boom. So this means we're going to edit task 102, which is this task right here, and we're going to give it a priority of 8. Boom. So we're going. So let's make sure, let's check over here. It says task manager edit 102.8 updates priority task 102 to 8. Right, so now we're going to edit, take edit, we come right here, we're editing this. So that means we look for task 102, and we're going to change its priority to 8. So now it has a priority of 8. We call that, we can get rid of it. Boom. Boom. So now we're on exec top. So once again, exec top, what that wants us to do is we're going to execute the task with the highest priority. Oh, hold on. Before we get there, let me make sure I change this one too. Boom. Okay. So now we're going to execute the task with the highest priority across all of the users. If there are multiple tasks with the same highest priority, execute the one with the highest task ID. After executing, the task ID is removed from the system, and we return the user ID associated with the executed task. If no tasks are available, we return -1. So right here, now we're right here. So we're calling exec top. As you can see, user 3, this task right here has the highest priority. This has a priority of 15. No other task has a priority that is above 15. That means this task has the highest priority. So we're going to remove this task, and we're going to return the user. So remember, this is user 3. So we can remove this task. Boom. This task has been completed. We don't have to worry about it anymore. And then we could just add 3 to our output. Boom. Then, so now what's next? Oh, and we could get rid of this. So get rid of this exec top right here. Then we could get rid of this right here. Boom. So now, okay, now we're remove 101. Boom. So it says remove 101, removes task 101 from the system. So we could just remove this task from the system. Boom. Boom. We called that. So we get rid of that as well. And then down here we get rid of it as well. Boom. Or I mean, we don't really need this, but hey, it should be the same as this. So boom. So then we did that. We could do another null because we didn't return anything. We just removed something. So then, oh yeah, we called this, so we need to remove this as well. So now it says we're calling add. So we're gonna add call function, the add function, and this is what we're going to add right here. Let's make sure that's right. It says task manager add 5-105-15 adds task 105 with a priority 15 from user 5. Right. So we're just going to take this. Boom. Sorry, y'all. Take this. Boom. And then we can add it here. Hold on, y'all. Sorry, y'all. Did we add it? No, hold on. So we could take this here, and then we could add it right here. Boom. Then we can add it right here as well, just because. Boom. So now we added it. We called that function. Boom. We didn't return anything, so we could say null again. Boom. And then finally, we're calling exec top again. Boom. So we can get rid of this. We get rid of this, and once again, exec top just executes the task with the highest priority. So right now, this is what we're left with. Well, we can get rid of this. It doesn't matter. This is what we're left with once, and then we can see user 5 has the task with the highest priority at 15. So we could just pass in 5 to our output. Boom. And now this is our output. Sorry, y'all. I forgot to put a no, but I think we went over it in the example. I just forgot to add it. But yeah, this is our output, and this is our input. Oh, excuse me, this is our output. This is our input got destroyed. But yeah, this is how the output should look. That's how we got it. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we are going to want to do is we're going to encode the user ID, task ID, and priority into a single uint so it can be stored in a max heap, right? So we're going to do it like this. We're going to come inside the class right here, and we're going to say let encode task equal, open up the brackets, open up the parentheses. We're going to say A colon, that's going to be int. Then we're going to say B colon, that's going to be int, comma, C colon, that's going to be int as well. And it's going to return, come outside of this, we're going to return a uint. Then we're going to say n. And we are going to, hold on, y'all. Sorry, y'all. This return right here. Sorry, y'all. This return right here should be come right here, still inside the bracket. So we're going to say, once again, return. Then we are going to say, excuse me, y'all. We're going to return. And it's going to be a uint. Then we're going to say n. Then we're going to come right here, and we're going to open up the brackets. We're going to say uint, open up the parentheses, C. Then we're going to say less than sign 34. Come outside of this parentheses. We're going to say plus, open up some more parentheses, same thing, uint. This time open up the parentheses, pass in B. Less than 17. Then come outside of that, and we're going to say plus uint, open up the parentheses, pass in A. Now this is going to lay out the bits from low to highest, right? So bits 0 to 16 is going to be user ID, bits 17 to 33 is going to be the task ID, and bits 34 on is going to be the priority. Now we need to decode the packed uint back into the user ID, task ID, and priority. So to decode the task, we are going to come right here, and we're going to say let decode task equal, open up the brackets, open up the parentheses, D colon uint, boom, come outside of these parentheses in the brackets again. We're going to say n. Then we're going to come right here, and we're going to open up the parentheses. We're going to say int, open up the square brackets, T, and one and sign 0x1 FFFF. Then we're going to come outside of these parentheses, still inside the other parentheses, and we're going to say comma. We come underneath it, and this time we're going to say int, parentheses, T greater than 17. Come outside of the parentheses, or the first parentheses, still inside the other parentheses, and we're going to say and one and sign 0 x 1 f f f f. Should be 4 f's. Then we're going to come outside of this. We say comma, come underneath this, and we're going to say int, open up the parentheses, T, greater than 34. Boom. Then just like that. Boom. So now we need a max heap of encoded tasks which will support quick retrieval of the largest encoded value, which corresponds to the highest priority / highest task ID. So we are going to come right here, create our heap, declare a variable, call it heap, set that equal to a heap, so less than UINT, greater than, and put the parentheses at the end. Boom. Now we need to map each task ID to its user using a dictionary. So we're going to declare a variable called users, set that equal to a dictionary of integers, integers. The key is an integer, the value is an integer, and put the parentheses outside like that. Then we need to map each task ID to its current priority. And then the priority of -1 means the task has been logically removed. So we're going to create another dictionary. So var priorities equals, and it's going to be a dictionary. Key is a dictionary. Key is an integer. The value is an integer again. Initialize it with the parentheses like that. Boom. Now it's time to initialize the manager with the initial list of tasks, and each element of task is the user ID, task ID, and priority ID. So we could lazily map each triple and insert into the heap and dictionaries by coming right here in this init. Let me just clean that up. So we're going to come in this init. We're going to say for, open up the parentheses, user ID, comma, task, sorry y'all, lowercase task ID, comma, oh sorry y'all, we're gonna say, oh actually no, that's right, and then we're gonna pass in the priority as well. So say priority, boom, like that. Then we're gonna say in task.lazy.map. Then we open up the brackets. Open up the parentheses, then open up the brackets, and we're going to say AN, open up the parentheses, we're going to say A, square bracket 0, comma, after the square bracket, A, square bracket 1, come outside the square bracket, comma, and then A, square bracket 2. Boom. Then we're going to come outside of these parentheses, and we're going to open up the brackets again. So we're going to open up the brackets, and we're going to say heap.insert, open up the parentheses, encode task, open up the parentheses, and we're going to say user ID, comma, task ID, comma, priority. Boom. Then we come underneath this, and we are going to say users, square bracket, task ID, and we are going to set that equal to user ID, and we're going to come underneath that. We're going to say priorities, square bracket, task ID, and we are going to set that equal to priority, just like that. Boom. Now we need to create our function to add a new task. So for that, we could just come in this add function, and we could say heap.insert, open up the parentheses, encoded task, open up the parentheses, pass in user ID, comma, task ID, comma, priority. Boom. Come underneath that, and we're going to say users, square bracket, task ID. We're going to set that equal to user ID. Then we're going to say priorities, square bracket, task ID. We're going to set that equal to priority. Boom. Now we need to create our edit function. So for our edit function, all we need to do is come right here and we can say add, open up the parentheses. We're going to say users square bracket t, come outside of the square bracket, and we could just say minus equals 1. Boom. Or come out, use it. No, we're not. We're going to say question mark, minus 1. Then we're going to say, sorry, question mark, minus 1. Then we're going to say, comma, t, comma, p. Boom. Then we come right here and we, for this remove function, this is the function where we are going to remove the task. We just say priorities, sorry y'all, these priorities, square bracket t minus equals 1. Now we need to do our exec top function. So for our exec top function, we come right here. We can say guard let task equal heap dot pop max. Put the parentheses. Then we'll say else. Open the brackets. We can return -1. Then we need to decode to get the user ID, task ID, and sorted priority by coming underneath this, and we're going to say let, open up the parentheses, user ID, comma, task ID, comma, p. We're going to say equals, sorry y'all, equals decode task, open up the parentheses, and passing task. Now we need to check if the entry is stale, or meaning the priority's been changed or task has been removed. If it is stale, we can skip it and recurse until a valid task is found. So we could use a guard statement for that. We'll say guard priorities. Open up the square bracket, passing task ID, come outside the square bracket, say equals p, else, open up the brackets, we can return exact top. Boom. And put the parentheses after that. Boom. Then we need to mark the task as removed, so future call skip it. So we just come underneath that and we say priorities, square bracket task ID, say equals -1, and then this remove function too, this should be equals -1, not minus equals 1. So equals -1. Sorry about that, y'all. Then now we're back down here and we are going to say return user ID. Boom. That should be all she wrote, y'all. Let's give it a run. And maybe some typos in here, but we'll see. Okay, cannot find encode task. So encode task. Let's see. Hold on. Let me see. Encode. Oh, it's a D right here. We need to get rid of that D. Let's run it again. See if this works. Cannot find encoded task. Just a minute. We need to run it again. Let's see. Cannot find T in scope. So let me see. Oh, sorry, y'all. So this shouldn't be T. We could just put this as, or we could change this to T. And we could change this to P. Just to keep it P. You feel me? Now let's run it, see if that works. Sorry, y'all. We're going to have to do that here too. I can see it now. Boom. Let's run it again. Wrong answer. Okay, so now that means we need to check the math Make sure the math is math, and when you get the wrong answer, that means the math probably isn't mathing right. So let's see where we went wrong with the math. Oh, sorry, y'all. This right here should be a plus sign, not multiplication. So let's change this from multiplication to a plus sign, and that should do the trick. Yeah, the wrong answer normally means it's something wrong with the math. There it is, y'all, and now it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 187 milliseconds beats 100% of users. That's what I'd like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom part, y'all. And with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.